Hi guys, this is Cassidy, and today we're going to be going over a colligative property vapor pressure problem. Okay, so it says the vapor pressure of pure water is 23.8 millimeters of mercury at 25 degrees Celsius. Assume 1 kilogram of water. What is the vapor pressure of a solution with 2.5 mol of glucose? Okay, so what do I do in this situation? I immediately write down my equation that I'm going to use, because that's going to help orient my brain and let me know what I need to find. If we look at our problem, it's asking us what is the vapor pressure of the solution. So let's find that variable. That's going to be P solution, right? It's the vapor pressure of the solution. So this is what we're solving for. So we need to find this and this in order to do this problem. Our X, remember, is our mole fraction. So our mole fraction, as a reminder, is our moles of our solvent over the moles of our solution. And then we also need our P solvent. Okay. P solution. We need our mole fraction and our P solvent. Let's see if we have any of those in the equation or in the problem. The vapor pressure of pure water is 23.8 millimeters of mercury. The fact that it says the vapor pressure of pure water is telling us that our water is our solvent here. And it gives us that pressure, so we can put that here, 23.8 millimeters of mercury. Now, all we have to do is solve for our mole fraction. So we need the moles of the solvent and then moles of the solution. Let's do the moles of the solvent first. It doesn't tell us the moles of solvent in the problem, but it gives us kilograms of water, and that's what we're going to use. How do I know we use that? Well, it's the only thing that is explaining the mass of water or the quantity of it. So what I can do is a little factor label method. So I know that there's 1,000 grams per 1 kilogram. And then I also know that the molar mass of water is 18.02. So all of these units cancel out, and I'm left with 55.6 moles of water. That, my friends, is our moles of our solvent. Okay, what about our moles of solution? So that's going to be the moles of our solvent plus our solute. We already have our solvent moles, right? 55.6. But now we need to find our solute moles. So let's go back into the problem and find our solute. Our solute is the glucose. It's the solid in this problem. We get 2.5 molal. What is molal? Well, that is the unit for molality. And if you remember, our molality equation is equivalent to the moles of our solute over the kilograms of the solvent, which in this case is water. So that actually makes this problem pretty nice. And what we're going to do is solve for our moles of our solute. And since we only have 1 kilogram of water, moles of solute has to also be 2.5, right? Because 2.5 divided by 1 is 2.5. So we add that back in right here, 2.50. So our total moles of solution is 58.06. Okay, let's back it up and make sure we have everything. So we have our moles of our solvent and we have our moles of our solution. Now we need to calculate the mole fraction of our solvent. Let's do that in green right up here. All we got to do is 55.6 over 58.06, and we're going to get 0.958. And now we can put that into there. So finally, our P solution is equivalent to 0.958 times 23.8, and we're going to get 22.8 millimeters of mercury. So your final answer is going to be right there. So that is an example of how you would solve a vapor pressure problem.